Okay, so in this video here, we're going to be talking about properties of exponents. And one thing that you have to know before doing the examples in this video are the rules for horizontal asymptotes, and I have them written right here. So there are going to be three rules here when you're dealing with a horizontal asymptote, and you can see that, well, it could be no horizontal asymptote. That would be your first rule. And it says n of x is greater than b of x. So again, they're giving you this polynomial p of x, and then n of x would be some polynomial, and d of x would be some polynomial. So they're saying that if the degree of n of x is greater than the degree of d of x, there's going to be no horizontal asymptote. Then the second rule, if n of x has the same degree as d of x, that means that they're going to have a ratio, and that's going to be the ratio between the leading coefficients. So you'll have y is equal to a over b, again being the leading coefficients there. And then the third rule, if the degree of n of x is less than the degree of d of x, you're going to have a horizontal asymptote at y equal to 0. Okay, so let's go ahead and take a look at our first example, and make sure you go back to this page if you need to as we go through the examples. So here's our first example, and what you always want to do when you're dealing with a rational function, you want to factor everything. Okay, so if you can factor, make sure you do that. So looking at my numerator, that is a difference of two squares. I can go ahead and factor that the following way. It's going to be x plus 1 and then x minus 1. Okay, and then on my denominator, I can pull out a negative 4. So I'm going to pull out a negative 4, and that will give me x and then plus 3. Okay, so there we go. It's completely factored. And then from here, if you look at what they're asking for the asymptotes, holes, intercepts, and domain. So your asymptotes are going to be vertical and horizontal here. So let's do the vertical asymptotes first, and that's really straightforward. You're just going to take the factors of your denominator, set it equal to 0, and solve. So I have two factors on my denominator. If I solve that first factor, I get negative 4 equal to 0. I can't solve for anything, right? So that doesn't help me. But then looking at this factor here, if I solve that one, I get x plus 3 equal to 0, and that will give me x is equal to negative 3. So I have a vertical asymptote at x is equal to negative 3. So I'm going to put VA here for vertical asymptote. I'm going to draw a line, and I'm going to say x is equal to negative 3. Okay, there's that one. So again, a vertical asymptote is essentially a value that's going to make the rational function undefined, meaning you'll have division by 0. So for example, if I plug in this negative 3 into x right here, then I'll have division by 0, and the whole thing becomes undefined. And so if you were to graph it, you would see that when you put on your vertical asymptotes, the curve is approaching that imaginary line that we call the vertical asymptote, but it does not actually touch, right? It's approaching. So an easy way to remember this, your vertical asymptotes will always be pertaining to your denominator, and whatever value is going to make your denominator equal to 0. So again, to find the vertical asymptotes, you take the factors of your denominator, set it equal to 0, and solve. Here I have one vertical asymptote. It's going to be at x is equal to negative 3. Now, to find a horizontal asymptote, you have to go back to the original. So looking at the original right here, I can see that on my numerator, I have a degree of 2. And on my denominator, I have a degree of 1 right here. Okay, so going back to that page that I showed you at the beginning, the degree on the numerator is bigger than the degree on the denominator. That means we have no horizontal asymptote. So I'm going to go ahead and put here HA for horizontal asymptote, and I'm going to say none. Okay, so that one's done. From here, we want to see if we have any holes. So holes are essentially going to be factors that cancel out. So if you look at what I have factored here, nothing ended up canceling out. Okay, so I'm not going to have a hole. So in this example here, we do not have any holes. We don't have to worry about it. But again, in the next couple of examples, we will have holes, and we'll talk more about that when that does occur. Intercepts, that just simply means where it's crossing the x and where it's crossing the y. So to figure this out, it's pretty straightforward. If you want to figure out where it's crossing the y-intercept, you're simply plugging in a 0 into x. So in other words, if you want to find the y-intercept, I'm going to put y-intercept here. You're going to do f of 0, meaning you're going to be plugging in a 0 wherever you see an x, because again, whenever it crosses the y-axis, which is your y-intercept, x will always be 0. And you can see what ends up happening here. This will always happen on all your rational functions. You're just going to be left with the constants. I'm going to be left with negative 1 and negative 12. Okay, so my y-intercept is going to be negative 1 over negative 12. And again, they're both negative. It will be positive. So that's a point. I'm going to say here, 0, comma 1 over 12. And then we're done. Here's my y-intercept, okay? Now, to find the x-intercept, it's a little bit different. We're going to be plugging in a 0 into y. Now remember, f of x is your y. So I'm going to set f of x equal to 0. And when you do that, what ends up happening, take a look at your denominator right here. I'm going to end up multiplying both sides by my denominator to get rid of it. And if f of x is equal to 0, that denominator will always drop out. So an easy way to remember this, if you're trying to solve for the x-intercept, you're simply going to set the numerator equal to 0 because the denominator will always drop out. Okay, so again, to find the x-intercept, we're going to make the y 0. So for us, that's going to be f of x. So f of x equal to 0. And again, we talked about how the denominator will drop out. That will leave me with x squared minus 1, which we know is x plus 1 and x minus 1. So you get x plus 1, x minus 1 equal to 0. And then when you solve that, you get x is equal to negative 1 and x is equal to positive 1. So if we scroll down a little bit here, we're going to go ahead and write that in. So I get here 1, comma 0. And then I get negative 1, comma 0. And then we're done. So there's my x-intercept, okay? And then from here, they want us to find the domain, and that's pretty straightforward. You're going to be looking at your vertical asymptotes here. So your vertical asymptotes give away your domain. I have one at negative 3. So my domain is going to be the following. I'm going to say domain, okay? And we're going to write it in interval notation. So I'm going from negative infinity to positive infinity. So negative infinity, right? And again, I'm using parentheses because I cannot be on negative infinity. And then I'm going to, well, eventually I'll hit this negative 3. Okay, that's my vertical asymptote. So I'll put negative 3. And again, I cannot be on it. So I'm going to close it with a parenthesis. And then I'm going to pick back up. But again, you do have a gap in your solution, right? I can't be on negative 3. I have a vertical asymptote there. That is a gap. So I put a union. And then I pick back up at negative 3 where, again, I can't be on it. So parenthesis, negative 3. And then I go all the way to positive infinity. And again, I can't be on infinity, so we're going to close it with a parenthesis. All right. And there it is. There's my domain. Okay. So why don't we go ahead and try another example? This one will be a bit more challenging. Okay, so here's our last example. And on this one here, again, we want to try to factor everything. And notice here that I'm dealing with a quadratic on both the numerator and denominator. That's fine. So we're going to factor our numerator. When I do that, you can use the AC method, or you can do it in your head. Doing the AC method in your head, again, a times c will give you negative 8. So I need two numbers when I multiply, that will give me negative 8, but add up to my 2 right here, my b value. So that's going to end up being positive 4 and negative 2. So putting that in factored form, I get x plus 4 and then x minus 2. Okay? So that will work. And then looking at your denominator, we want to go ahead and factor that. So first, I'm going to go ahead and pull out a 3. Okay, so I'm going to go ahead and put 3 right here just for now because I know that I'm going to factor that out. And then off to the side here in a different color, I know that I'm going to be left with x squared plus x and then minus 12. Again, pulling out that 3. And from here, I can factor it. So two numbers when I multiply, that will give me negative 12, but add up to 1. Well, that's going to be 4 and negative 3. So in factored form, that's going to be x plus 4 and then x minus 3. So we're going to go ahead and write that down here. So we get x plus 4 and x minus 3. Okay, there it is, completely factored. So again, that is always your first step when you are solving these rational functions or describing the properties of them. You want to make sure that you factor everything. And again, this is f of x. So f of x is equal to the following. Now, from here, we want to go ahead and figure out our asymptote. So look at your denominator, and you see that you have 3 factors. I have one factor here, here, and here. But technically, that factor of 3 is not going to help us if I set that equal to 0. So I don't need that. But before you do this, make sure that you don't have any common factors that are going to cancel out. So for example, at first glance, it may look like you have a vertical asymptote at x equal to negative 4 and x equal to 3. Again, if I solve this factor here and this factor here. But you don't. You actually only have one vertical asymptote here, not 2. And that's because you have a common factor. Right here, I have x plus 4 and x plus 4. So if that occurs, you need to go ahead and cancel them out. So I'm going to go ahead and cancel these out. All right. And then you're going to be left with the following. We're going to go ahead and scroll down. That way we have room. So rewriting it, we have f of x equal to x minus 2 all over 3 times x minus 3. Okay. So now determining my vertical asymptote is going to be easy. I know that I just need this factor here. So my vertical asymptote, or VA, is going to be the following. If I solve that factor, I get x is equal to positive 3. There it is. Okay. So from here, let's get the horizontal asymptote. And you're going to get that by going back to the original rational function. So right here, look at your degrees on this function. Notice that they're both going to be 2. So this is where I divide out the leading coefficients. So for example, my horizontal asymptote is going to be the following. I have a coefficient of 1 here in front of x squared, and then I have a coefficient of 3 in front of this x squared. And I know that those are going to be my leading coefficients. So I'm going to simply divide these out, meaning I'll do 1 divided by 3. That's going to be my horizontal asymptote. So we're going to say y is equal to 1 over 3. And this one's done. All right, so we have the vertical asymptote, we have the horizontal asymptote. Now let's go ahead and talk about the holes. On the first example, we did not have any holes because we did not have a common factor that canceled out. But this one, we do. We do have a hole on this rational function. And it's going to be on this factor right here, x plus 4. So if you were to solve that factor by setting it equal to 0, you're going to get x is equal to negative 4. That's where your hole is going to occur. So I'm going to go ahead and put here hole. Okay, and I'm going to say x is equal to negative 4. Okay, and so what ends up happening here, it will be undefined at that point. It's going to be very similar to as if you were doing division by 0. But the only difference here is that you had a common factor and it canceled out. So it's not going to be a vertical asymptote. It's literally going to be a hole in your graph. Like, so if you were tracing this function and you were tracing that curve at negative 4 on the x, it will be undefined. And typically what they do when they're graphing the function by hand, you would show it by using an open circle like this here. So like, let's say to the left of this hole, you have the curve going like that, okay? And then to the right of it, you have something like this here, okay? But at this particular point right here, we have a hole and it's undefined. So if you were to trace it, you would see that on the y value, it is undefined because technically it is division by 0. But again, since we had a common factor, it canceled out. So it didn't result in a vertical asymptote. Rather, it resulted in a hole in the graph, okay? And that's all there really is to it. So we have our hole, we have a vertical asymptote, we have a horizontal asymptote. From here, we want to get the intercepts and then the domain, all right? So remember, to get the x-intercept, we're simply going to plug in a 0 into our y, which is f of x. And we talked about how that's going to drop out our denominator, right? So let me go ahead and scroll down here. We know that to find the x-intercept, okay, we're going to do f of x equal to 0. And we know that the denominator will naturally drop out here. And so when you do this, you want to make sure that you're using the simplified version, which is going to be right here, okay? So we talked about how our denominator will drop out. Essentially, all I'm doing is x minus 2 equal to 0. And when I solve that, I get x is equal to 2. That's going to be my x-intercept. So as a point here, I would say 2, 0. There's my x-intercept, okay? Now to find the y-intercept, we're going to be plugging a 0 into x. So y-intercept, we're going to be doing f of 0, okay? And we talked about how the result will always be your constants, okay? So if I plug a 0 into x here, what am I left with? And you may have to go back to the original. That way you can see what will happen here. So if you plug a 0 in, if I scroll up, you're going to see that you're going to be left with -8 and -36, okay? And when you do this, you'll end up getting a +8 over 36. Okay, so that will be my y-intercept value. I'm going to go ahead and put here 8 over 36. And we can go ahead and reduce that down. We know that 4 will go into 8 2 times. And 4 will go into 36 9 times. So 2 over 9. So as a point, you can go ahead and write 0, 2 over 9. There is my y-intercept, okay? And then finally, to find your domain, that will always be in respect to your vertical asymptote and also your hole. We do have a hole here. So again, imagine that you're going left to right here from negative infinity to positive infinity. Which one will you hit first? Will you hit that hole or will you hit that vertical asymptote? And I will hit the hole first. So what I'm going to do is the following. I'm going to say negative infinity to -4. Again, I can't be on it. And then union. And then I go from -4 to, well, then I'm going to hit my vertical asymptote, which is 3. Okay. And then union. And then I go from 3 finally to positive infinity, close it, and there you are. It's done. Okay. That is going to be your domain. All right. So that is properties of rational functions. It's kind of a lot, but once you get the hang of it, it's not too bad. Just remember, whenever you're doing these problems, you have to make sure that you factor it before doing anything. That's always step one. So again, make sure that you always factor. And that's it. So I hope that you found the video helpful. I hope that you gained something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.